There is a $22 part hiding inside your Toyota's suspension right now. And if it has been in there longer than 5 years, it is probably already falling apart. Most Toyota owners never think about it. Mechanics rarely mention it. And Toyota does not exactly advertise it during your $300 dealer visit. But this one overlooked component controls how your car absorbs every single bump, pothole, and expansion joint on the road. Replace it with the right upgrade, and your Toyota suddenly rides smoother, quieter, and more controlled than it has in years. In some cases, it transforms the ride so dramatically that owners compare it to the effortless glide of a Lexus LC, a car that starts above $100,000, and the part itself costs roughly $22. Let me explain exactly what it is, why it matters this much, and why almost nobody talks about it. Let's start with what's actually going wrong inside your suspension. Every Toyota, whether it's a Camry, Corolla, RAV4, Highlander, Tacoma, or 4Runner, uses a component called a bump stop. Some Toyota service manuals call it a jounce bumper. Others call it a strut bumper or a spring bumper. Regardless of the name, the job is the same. Bump stops sit inside or on top of your suspension struts and shock absorbers. They're usually made of a soft foam rubber compound, and their entire purpose is to cushion the suspension when it compresses fully. Think of it this way. Your struts and shocks handle normal road movement. They compress and extend thousands of times per mile. But when you hit a deep pothole, a speed bump at full speed, or an uneven section of highway, the suspension compresses all the way to the end of its travel. Without a functioning bump stop, that's a metal-to-metal collision. The strut rod slams into the strut housing. The shock piston bottoms out against its internal stop, and every ounce of that impact energy transfers directly into the chassis, through the seats, and straight into your spine. Factory Toyota bump stops prevent that. But here's the problem nobody warns you about. Those factory foam rubber bump stops are designed to be disposable. Toyota engineers know they degrade. The foam material dries out, cracks, crumbles, and eventually disintegrates inside the strut assembly. On many Toyotas with 60,000 to 80,000 miles, the original bump stops are already half gone. By 100,000 miles, some have completely disappeared. And because they sit hidden inside the strut boot or deep inside the shock assembly, most owners never see the damage until the ride quality has already fallen off a cliff. Now here's where the comparison to the Lexus LC becomes relevant, and it's not as far-fetched as it sounds. The Lexus LC 500 uses one of the most advanced suspension systems ever fitted to a production car. It's called adaptive variable suspension, and it can adjust damping force across 650 individual levels. That system uses electronic sensors for G-force, yaw rate, vehicle speed, and steering input. It reads the road surface and the driver's behavior in real time, then adjusts each shock absorber independently, multiple times per second. The result is a ride that feels impossibly smooth at highway speed and surgically sharp through corners. Lexus spent hundreds of millions developing that system. It's the reason the LC floats over imperfections that would rattle a normal car, and it's a major reason the vehicle costs over $100,000. But here's the engineering principle that connects a $22 bump stop to that $100,000 suspension system. The Lexus LC achieves its ride quality through progressive damping. That means the suspension responds gradually to increasing load. Small bumps get a soft response. Bigger bumps get a firmer response. The system never hits a wall. It never bottoms out harshly. It simply increases resistance smoothly as the suspension compresses deeper. That progressive behavior is exactly what a quality aftermarket bump stop replicates inside your Toyota's suspension, not electronically, not with sensors, just through material science and geometry. Factory Toyota bump stops are made from closed-cell foam rubber. When new, they provide a basic cushion, but the compression curve is steep and inconsistent. The foam compresses quickly, then hits a hard stop almost immediately. There is no gradual buildup of resistance. It is soft, 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 then wall. That is why even a brand new Toyota can feel harsh over sharp bumps. The bump stop does its job technically, but the transition from suspension travel to full compression is abrupt and uncomfortable. Now compare that to a performance-grade polyurethane bump stop. Companies like Energy Suspension and Prothane manufacture direct-fit polyurethane replacements for Toyota strut and shock bump stops. These parts typically cost between $18 and $25 for a pair, depending on the model, and the difference in material behavior is enormous. Polyurethane bump stops are engineered with a progressive compression rate. That means the material starts soft and gets gradually firmer the more it compresses. There is no hard wall at the end of travel. Instead, the resistance builds smoothly, absorbing energy in a controlled, linear fashion. It is the same damping principle that the Lexus LC uses electronically, except here it is built into the physical structure of a $22 part. When a polyurethane bump stop compresses under load, the energy dissipation curve looks completely different from factory foam. The initial contact is gentle, the mid-stroke resistance increases steadily, and full compression feels firm but never harsh. That gradual energy absorption is what transforms how the car rides over rough pavement, railroad crossings, parking lot entrances, and broken highway surfaces. The ride-height connection is something most people never consider, but it matters more than you would expect. When factory bump stops degrade or disappear entirely, the suspension loses its end-of-travel cushion. That means the strut or shock can now compress further than Toyota originally intended. On the surface, that sounds like more travel should be a good thing, but it is the opposite. Without a bump stop to control the final inches of compression, the suspension slams into its mechanical limit. That impact sends shock waves through the strut mount, the upper spring perch, the lower control arm bushings, and the steering knuckle. Over time, those repeated impacts accelerate wear on every connected component. Strut mounts start clicking. Spring perches develop play. Control arm bushings crack. And the overall ride height can actually drop slightly as the upper strut mounts compress and deform under loads they were never designed to absorb alone. When you install a fresh set of polyurethane bump stops, the suspension regains that end-of-travel control. The strut no longer bottoms out against bare metal. The loads are distributed more gradually across the full compression stroke. And in some cases, owners report that ride height stabilizes or even recovers slightly because the upper mounts and spring perches are no longer being hammered into deformation. It is not a lift kit. It does not raise the car, but it restores the suspension geometry closer to what Toyota engineered from the factory, which affects everything from tire contact patch to steering response. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. Let me explain why this matters so much on specific Toyota models. On the Camry and Corolla, both of which use McPherson strut front suspension, the bump stop sits directly on the strut shaft inside the dust boot. As the strut compresses, the bump stop contacts the upper spring seat and absorbs the final inches of travel. When this part disintegrates, The strut piston rod can slam into the upper mount with nothing to cushion it. Owners often describe this as a loud clunk or thud over sharp bumps. Many pay $400 to $800 for strut replacements when the actual problem was a $22 set of bump stops that crumbled away 3 years ago. On the RAV4 and Highlander, the problem is even more pronounced because these vehicles are heavier and carry more cargo. The additional weight means the suspension compresses deeper more often, and the bump stops take more abuse. RAV4 owners who tow, haul gear, or frequently drive with a full cabin are especially vulnerable. The rear shock bump stops on these models can deteriorate rapidly, and most owners attribute the worsening ride quality to aging shocks, when the real culprit is a disintegrated foam bumper that costs less than a tank of gas to replace. On Toyota trucks and SUVs like the Tacoma and 4Runner, the bump stop issue becomes even more critical. These vehicles use body-on-frame construction with leaf spring rear suspensions in many configurations. The rear bump stops mount between the frame and the axle, and they are directly exposed to road debris, water, mud, and temperature extremes. Factory rubber bump stops on these trucks often crack and fall apart well before the shocks or springs show any sign of weakness. When they are gone, every off-road trail, gravel road, or heavy payload scenario sends unfiltered impacts straight through the frame. Aftermarket polyurethane bump stops designed for these trucks, from companies like Energy Suspension and Prothane, are built to resist ultraviolet degradation, chemical exposure, and extreme temperature cycling. They do not dry out. They do not crumble. Their progressive compression rate means the transition from suspension travel to full compression feels controlled instead of violent. Here's something even experienced mechanics overlook. When you replace only the shocks or struts without inspecting the bump stops, you are putting new dampers into a system that is already missing a critical safety component. The new struts will feel better initially because they are providing fresh damping through the normal travel range. But the moment the suspension compresses fully, the same harsh bottoming out returns because there is nothing at the end of travel to catch it. That is why some Toyota owners spend $600 to $1,000 on brand new struts and still complain the ride feels harsh over big bumps. The struts are fine. The springs are fine. The missing or crumbled bump stops are letting the entire assembly slam into its limits unprotected. A $22 set of polyurethane replacements would have completed the job. Now let me address the concern some owners have about polyurethane being too stiff for daily driving. This is a common misconception that comes from confusing bump stops with suspension bushings. Polyurethane suspension bushings, such as sway bar bushings or control arm bushings, do sit in the load path full time and can transmit more road noise than rubber. But bump stops are different. Bump stops only engage at the very end of suspension travel. During normal driving over smooth roads, the bump stops are not doing anything at all. They sit there waiting. They only activate when the suspension compresses deeply enough to make contact. And when they do engage, the progressive compression rate of polyurethane actually provides a smoother transition than factory foam. You do not feel the bump stop working. You feel the absence of that harsh bottoming out that you have been living with for years. The ride does not get stiffer. It gets more controlled. And that difference is exactly what makes the Lexus LC feel so composed. Not raw stiffness. Controlled, progressive energy absorption that never lets the chassis feel unsettled. There's also a financial argument that makes this upgrade almost mandatory for any Toyota owner planning to keep their car past 100,000 miles. When bump stops fail and the suspension repeatedly bottoms out, the cascade of secondary damage starts quietly and accelerates over time. Strut mounts absorb impacts they weren't designed for and develop bearing noise. Upper spring perches deform and create alignment inconsistencies. Control arm bushings crack prematurely from transmitted shock loads. Steering components develop play because the knuckle connections take repeated hammering. Over time, a car that simply needed $22 in bump stops now requires $1,500 to $2,500 in suspension repairs across multiple components. That's the real cost of ignoring this part. Not the bump stops themselves, but everything they were designed to protect. Here's the final detail that separates informed Toyota owners from everyone else. When you install new polyurethane bump stops, you're not just replacing a worn part. You're upgrading the physics of how your suspension handles its worst-case scenario. Factory foam gives you one chance to absorb impact energy. It compresses, it bottoms out, and the energy passes through. Polyurethane gives you a graduated response curve that manages energy across the full compression stroke. That's the same philosophy behind every luxury car suspension on the market. The Lexus LC just does it with computers and $100,000 worth of engineering. Your Toyota can achieve a meaningful version of that same result for $22, a set of basic hand tools, and about 45 minutes of time. The ride quality improvement is immediate. The protection it provides is long-term. And the fact that almost nobody talks about it is exactly why so many Toyota owners spend thousands fixing suspension damage that a $22 part would have prevented entirely. If you're enjoying this video, consider watching this one, where I'm sharing more ways to make your Toyota last beyond 300,000 miles.